and we've done some of these before, but I just want to get them on film because some of you have struggled with them. It says, this one here, it says, a fox sees a piece of carrion being thrown from a hawk's nest and rushes to snatch it. So the fox is here, this is the fox. It's being thrown from the nest and it's going to hit the ground somewhere here between the base of the tree and where the fox is sitting. Okay? That's the problem. The tree is 20 meters high, clear? And it's thrown at 2 meters per second. Clear? Now, it says the fox is 20 meters from the base of the tree. That's 20 meters right there. Okay. What is the magnitude of the fox's average velocity if it grabs the carrion in its mouth just as it touches the ground? Assume no air resistance. Always use, unless it's a multiple choice problem, I would use K, meters per second squared. It's easier. Okay? So, right. So, if it's going 2 meters per second horizontally, how long is it going to be in the air? Well, if it's 20 meters tall, it's going to be in the air 20 over 5, right? Yes, equals T. Because we know T equals 5T squared. All I'm doing is I'm solving for T. T divided by 5, square root. Clear? So that's going to be T is obviously going to be
2 seconds.
2 seconds. Correct? Tx is also 2 seconds. Right? So this is going to be 4 meters. It's going to fall 4 meters from the base of the tree. Easy? Yes? Now, if the fox is 20 meters from the base of the tree, how far is the fox from the piece of meat? 16 meters. So it's got to go 16 meters in how many seconds? 2 seconds. So it's got to go flat out 8 meters per second, which is pretty fast. I'm not sure you could run. I certainly could run 8 meters per second. Frame sustained length of time. Okay? So, that's the end of that problem. Clear? And what I'll do is I'll clear that problem off. No, let it go. Let it go. We'll do both problems. I have a second problem that I'm doing here that I put next to it here. Okay? Okay? So this next one is the pebble from falling. It says a pebble falls vertically from a ledge of a cliff 100 meters high. So it's falling vertically, it's falling straight down, okay? Now, after 2 seconds, the pebble glances off a small rock protruding from the face of the cliff with a horizontal velocity of 10 meters per second. So somewhere it's going to glance off horizontally at 10 centimeters per second. Now it says, just to clear things up, however, the pebble is deflected perpendicular to the face of the cliff with a horizontal velocity of 10 meters per second. Okay, now, it says the impact with the ledge has negligible effect on the pebble's vertical motion. Clear? So it's not going to interfere with the time it takes for the pebble to drop. Now, the pebble is going to drop for 4.4 seconds. Clear? Yes? So, it's going to fall for 2 seconds, and then it has 2.2 seconds to go, correct? 2.4 seconds. Right? Is that correct? 2.4? Yes? So this is wrong here. So if it's going to go for 2 seconds, then it will go at that velocity horizontally for 2.4 seconds. So 10 times 2.4 would be 24. So this distance here will be 24 centimeters. Is that right? Correct? Easy? Any questions on that? Is that filming okay to that side? Is it okay? All right, finished. Okay? All right, you can turn that on. Thank you. I'm not done yet.